Okay, so I'm quickly going to create a new project. Just say Java application. Next, this will be my week 5 series of demos. So I'm just going to name this week 5. I will create the main class and name it main app, as this is my habit to name main classes when I need to create them. Okay. So let's just have some more space to write our code. And then I'm going to go to my package and add a class named product, right? Product. So that's fine. Finish. The same package. The class name product. So then this is class name product. Then we're going to save everything and add another class named book. Okay, so this is book, this is product, and just as we normally do, we will modify this to say extends product, right? Extends product. So we have this book. Let's just make this very simple. We have these two classes. They're both empty. So this is still a valid arrangement. That's okay. The classes can be empty. And see what we can do in our main method right here. If we can say what that example did on the slide. So I can try copying and pasting this section right there and just say, as always, source format helps to keep things in check. So we say, all right, how about this? We say, let's create new book, but remember the reference to it as a product, and then say get class, get name, and compare that name with book string. And if everything works, it's going to say this is a book object. So run it. So if everything's fine, it should compile properly and run it. And here, it didn't print it. Else, let's find out why or what exactly did I do incorrectly in this example. This is an object of type, and we're going to repeat this piece, right? We're just going to get the name and print what this is, just to find out what fell apart in this particular example. So let's save that, run it. It says this is an object of type week 5 book. So that's the reason why it didn't work, because actually the package name, since the package name is fully qualifying the name of the class, it is actually included in our current Java implementation. The name of the package, such as week 5, is actually included in the name returned by this get name. So therefore, if I said, if I said week 5 dot book, when I did my comparison, that should print this is a book object, right? So that's just a little technicality that you have to remember. Let's do another example of how you can find out at runtime what is the class, what is the specific class that your reference is pointing to. And to do something like that, we can repeat this by saying, we already created new book. Instead, I'm just going to say if if my object reference is a is indeed an instance of the book class, then let me once again format the source. Here, source, format, arrange everything nicely. This is a book object. So let's see how instance of is going to behave in this particular example. So the second time this message is printed, therefore, in order to do this type of check, you have those two choices, and you can use either the class object which has the get name, or you can use the instance of, which is I think is a much better choice. It is a much better choice. Class objects can also be used to load instances of classes dynamically. Essentially decide at runtime what type of object you want to instantiate, instead of just saying, hard-coded name of a class. But once again, there are better alternatives, like, for instance, using design patterns for class factories or other creation patterns, which we will discuss in the future. Right, but this is a good demonstration of an instance of, and I think I would certainly prefer using instance of in my code whenever I can to give this preference over the ability to use class.